Hello. From the previous question, I just have to make one small correction here. When I was subtracting 1 over 12 from both sides, I forgot the negative sign right over here, which should carry that over here as well. But now then, let's look at the next question. What positive number is 8 more than? It's reciprocal, so positive number, I don't know what it is, so I'm going to call that as x, is equal to 8 more than, it's reciprocal. So now that's basically what we have to solve. So why don't we try to multiply by x on each side, so we get x squared is equal to 1 plus 8x. Then we get to have some sort of a quadratic equation. So I'm going to bring 8x over to the other side. So x squared minus 8x equals 1. Now, which number do I need to complete the square? Divide this number by 2 and then square that. Then it becomes 16. So I'm going to add 16 on both sides. Then on my left side, we get x minus 4 squared. On my right side, I get 17. So therefore, x minus 4 must be equal to plus or minus square root of 17, which is greater than 4, by the way, because 4 is square root of 16. So when I add 4 in each side, x becomes 4 plus square root of 17 or minus. But the thing is, what they're looking for is positive numbers, so x must be equal to 4 plus square root of 17 would be our correct answer. All right, let's look at number 4 here. G of x is given in this manner. For some constant a, g of 3 is equal to negative 59. Find all possible values of a. So what we're going to do is we're just going to plug in first. So negative 59 must be equal to negative 7 times a times 3 goes in place of x. We get 9 plus 3a squared times 3 plus 13. Now, then I can rewrite this one as I'm breaking as I add, or as I actually subtract 13, then we get negative 72 must be equal to negative 63a, and then plus 9a squared. So when I divide by 9 on each side, then this becomes negative 7, this becomes negative 8. So here we get negative 8 is equal to, I'm just going to write down a squared first, a squared minus 7a. What do we need to complete the square? So I'm going to divide this one by 2, which is negative 7 over 2, and then square that, then I'll be getting negative, or positive rather, 49 over 4. So I'm going to add 49 over 4. Then, since 8 is 32 over 4, so when we subtract it, then it becomes 17 over 4, which is equal to a squared, or I'm going to just factor the other side here as well. So a minus 7 over 2 squared. So then obviously a minus 7 over 2 must be equal to then plus or minus 17 square root of 17 over 2, because when you take the square root of 4 it becomes 2. So then when I add 7 over 2, then a must be equal to 7 plus or minus square root of 17 over 2. That would have become our answer. All right, let's move on to the next question. Find the root of each of the following quadratic equations. So here what I'm going to do is I'm going to divide by 2 first. Why not? We get x squared plus 17 over 2 x is equal to negative 21 over 2. Now, obviously I'm going to divide this one by 2 and then square that. Then it becomes, I'm going to add 289, which is a square of 17 over 4, plus 289 over 4. Then on our left side, we get x plus 17 over 4 square becomes our perfect square on the left side. How about on the right side? I can just double that, becomes 42. So we get 2, 4, and then 7 over 4. Now, when I take the square root of each side, then we get x plus 17 over 4 must be equal to plus or minus square root of 247 over 2. So when I subtract 17 over 4, then we'll end up getting x will be equal to negative 17 over 4 plus or minus 247 over 2 becomes our answer. How about the next question here? When I subtract 1, then I get z squared plus 4z plus 4 equals negative 1. See, I could have subtracted 5 and then add 4 to it, or if you see the number rather nice, then you can just go to the number right away. Here we get z plus 2 squared is equal to negative 1. Then z plus 2 must be equal to plus or minus square root of negative 1. That means plus or minus I. That's what we're looking at. So what is z? Z is equal to negative 2 plus or minus I. That becomes our final answer. How about number B? Here I'm gonna first try to subtract 51 from both sides. Then y squared minus 16y is equal to negative 51. Now, of course, I'll be dividing this one by 2 and then square that becomes I'll be needing 64. So I'm adding 64 on each side. Then on my left side, we get y minus 8. Square must be equal to 13. So then y minus 8 must be equal to plus or minus square root of 13. And then y must be equal to 8 plus or minus square root of 13 as well. Alright, now, how about number D? Here, what if I divide, because I have x squared and I have square root of 5, and then that seems to be common in some places. So what if I divide by square root of 5? Then these two cancels out. We are left with x squared minus. See, radical 5 cancels out with radical 5, becomes 8. How about 10? Did you realize that 10 is equal to, if I write it on the corner, 10 is equal to 2 times 5. Well, you can rationalize this one if you want to, but that's equal to 2 times radical 5 times radical 5 as well. You can think of it that way as well. Then it'll be quite easy for you to cancel out radical 5 and radical 5, which gives you plus 2 radical 5 x, and then the last one is plus 20, and same manner here, plus 8 square root of 5. Now, then let me try to look at this one for a second. I need to in order for me to get the perfect square, I need to divide this one by 2. Then I get 4 plus square root of 5, and then next one is I need to square that. What do I get then? I get 4 squared plus 2 times 4 times radical 5 plus radical 5 squared. Then you can see that this becomes 4 squared becomes 16 plus 5, which ends up being 21 plus 8 square root of 5. That's what I need to make this one into perfect square. But I have 20, so therefore all I have to do is simply add 1 more to each side. Then I'll be getting x squared minus 8 plus 2 square root of 5 x plus 20, or actually 21 rather, plus 8 radical 5, which is equal to 1. Then now I know the left side is perfect square, as in x minus 4 plus radical 5. Square is equal to 1. then you can see that here x minus 4 plus radical 5 is equal to plus or minus 1, because square root of 1 is equal to 1 anyway. So then x then must be equal to 4 plus square root of 5 plus or minus 1. That means first answer can be 4 plus 1. We get 5 plus square root of 5, or 4 minus 1, we get 3 plus square root of 5. Those two becomes our answer. So here we are looking at the given function, and we want to find out the value of t, so that g of t will be equal to negative 13. Let's try to get started here. So I'm going to plug in negative 13 in place of g of t. So here we get negative 13 is equal to 2t squared minus 8 square root of 5t plus 25. Now, I can subtract 25 from both sides. Then you will see that I will end up getting negative 38 equals 2t squared minus 8 square root of 5t. To make things a bit simpler, I can divide everything by 2, then we get negative 19, which is equal to t squared minus 4 square root of 5t. Then at this point, what do you need to complete the square? So you're going to divide this one by 2, which would have been negative 2 square root of 5, and square that. It becomes in fact 20, so I'm adding 20 here on both sides. Then you can see that 1 is equal to 20 minus 19, t squared minus, well, maybe I'll just factor the right side as well as I'm doing it. So this one on the right side, it should becomes t minus half of that, which is 2 radical 5 perfect square. Then when I take the square root from both sides, then I get plus or minus 1, which will be equal to t minus 2 square root of 5. Now to have the t by itself, I have to add 2 square root of 5, so I'll be getting plus or minus 1 plus 2 square root of 5. That should be the value of t. Alright, then let's look at the last question. Find all z such that this is true. Now first what I'm going to do is I'm going to move this term to the other side. We get the z squared minus 3 minus 8i z is equal to 14 plus 12i. Now I'm going to take the middle term, the coefficient of z, divide that by 2, we get basically negative of 3 minus 8i over 2. That's what I'll be getting. But when I square that, I'll be getting, denominator becomes 4. The numerator, negative sign disappears basically. We get 9 minus 48i, and then minus 64, because it's supposed to be 8 squared becomes 64, but I squared make it into negative. So then here we end up getting 55, negative 55 minus 48i over 4. So I'm going to add that up to both sides. Then I end up getting negative 55 plus 48i over 4. This is another way for me to write it, because this negative sign will affect not only 55 but also 48 as well. On the right side, I'm going to do the same thing. So here, 55 plus 48i over 4. But one thing that's interesting is this becomes positive 12i. With the negative sign, that makes it into negative 12i, which cancels out with this one. So when I complete the right side, I will end up getting 14 minus 55 over 4. Now 14 is in fact 56 over 4. So therefore we end up getting 1 over 4 on the right side. How about on the left side? we'll end up getting z minus 3 minus 8I over 2 square. Now, of course, when I take the square root, then z minus 3 minus 8I over 2 becomes plus or minus 1/2. So then, when I add 3 minus 8I over 2, then z becomes 3 minus 8I over 2 plus or minus 1/2. So let's think about it. If I were to add 1/2 to this one, then my first answer becomes 4 minus 8I over 2, which becomes 2 minus 4I. On the other hand, if I put the minus 1/2 to that, then we get 2 minus 8I over 2. So therefore, our answer becomes 1 minus 4I. So one of these two becomes our answer. All right, I'm going to stop here, and I'll see you later. Bye-bye.